And the only reason I let him read that nonsense is because we're stalling on getting the computer up. And I do get the question, do I have a clicker too? I get the question, grand software testing. What is so grand about your software testing? Absolutely nothing, in fact. Where I live in the United States, the county I live in Colorado, is called Grand County. About every fifth or sixth business is Grand Plumbing, Grand Electric, Grand something or another. And when the state said, what do you want to call yourself? I was like, well, I'll just go with the local flow and things. And without coordination, mind you, between Eric and John and myself, and later Tom getting up, I think there's like some common themes running through here, which are maybe signs of weak consulting minds, resulting in the same information flow. And I also want to point out, since we're dealing with analytics and metrics, my parents analyzed my life and how to improve it, and changed the spelling of my name, John, by removing the H. So by my calculation, I've gained about 40 hours in my lifetime savings over John with the H. Not that you have to name your child like B or A or something like that to gain those kinds of improvements. But I do want to talk about analytics, and something I've been talking about this year at some conferences, which is architectures and environments and how these things play together to improve testing. And I'm really going to focus less on the organization, although I'll cover that a little bit, but I really want to challenge you all as testers to work to improve yourselves. And what I mean by that is I do a lot of teaching. Was in a big company for a long time. And what I found is that in many ways, real change for the organization starts with you all and the individual. And what I mean by that is I instituted a lot of change in my organizations by the things I did. And I'm going to tell you about some of those things, to the point that the gentleman that will be up after lunch, Tom, came and drugged me into this lovely world of consulting and teaching and things like that, because I changed organizations by changing myself first. Grand chart here, software's everywhere. Analytics, we see big data, we see analytics kind of everywhere. Everybody has various topics that become the thing of the day. Big data, analytics, AI are the ones that are out there today. But how do we support those into testing? And as I looked at the data that I had, it led me from analytics, and we'll get through that, into test architectures and test environments. And so I want to hit on those themes today a little bit. Why? Because you all ultimately want to be winners, right? You want good careers. And those kinds of things that lead one to hopefully happiness. And I realize that sounds kind of esoteric, but really, I've had a great career. I think some of the other consultants have had great careers. My lovely better half up here, my wife, who will talk later, helped in those things. And that's really what I wanted you to lead towards. So this is just obligatory, what are the topics I'm going to hit today a little bit. Kind of the things that I'm thinking about. Architectures, analytics, environments, perspectives on testing. I'm going to step through those kinds of things. The one that may be of direct interest to you are future work opportunities. Now, I know a lot of people come hoping to, maybe have me give you a job. Bad news there is I don't work much anymore. I'm a part-time, semi-retired person. I come here to do these things for you because this is fun for me. And I drag my poor wife along because I get lonely So, so I make her talk also, and you had to come hear her talk because she doesn't like to talk as much as I do. She says I never shut up, which is kind of strange for an introvert. By the way, I'm introverted. You wouldn't guess that, but it's true. Later on today, after talking today, tomorrow, I'll go curl up in a little ball after dinner and I'll sail a lot. Which, by the way, makes my wife happy on those things. So, what is all this technology stuff? It started out, by the way, a long time ago by making some tools and out of stone and things like that, back in the Stone Age, literally. And those are some of the first examples of human ingenuity and tools. Those are physical systems. And you step forward, yeah, that was 100,000 years ago, and we started building factories and cities, and the Industrial Revolution happened. And it's a little scary for some of us. Tom's got me beat. I think maybe Michael's got me beat. There's probably not. But I've been doing this software stuff for 40 years. I think Tom a little bit more. I think Michael a little bit more. But there's not many of us that have been doing software for longer. And that started somewhere in the 1950s. Yeah, you can go a little bit earlier. The scary thing there is the world's first software tester, or at least who a lot of us credit as being the world's first software tester, about 2 weeks ago died. Jerry Weinberg just passed away, which was a little traumatic to many of us, by the way. But how many industries are there out there that the founding fathers were still alive just not long ago? There's not many of us. And yet, what's going on with these systems is they've gone from, yes, I work with punch cards, Tom worked with punch cards. Not too many other people probably in the room work with computers and punch cards, but a few of us, where we're now got these cyber-physical systems that are controlling our world, our lives, our cars. Anybody afraid of cars driving themselves? A little bit. We talked about that last night a little bit. I'm not as afraid as most because I have older cars. I don't trust them just yet. But we're faced with how to test these things, and as several of the speakers pointed out, it's growing faster and faster. I used to think that testing 100,000 lines of code was a lot. You know, now my phone up here, or actually down there, because I left my phone is my second wife, by the way. Why? Because it tells me what to do all the time. I need my phone. I need my first wife even more. But there's 20 to 30 million lines of code, probably more, floating around in that thing. I don't know how to test that much. You know, that's like way too much on these things. So we went from the basic PCs and those kinds of things on systems, and we started hooking them together. I was on the internet web systems in the very early days. I actually, for a while, held a patent on web testing technology. I got some nice awards for that and let it go. It's now very common, most of the web tools out there. I moved into mobile embedded devices, as the little promo said. I was actually one of those rocket scientists, people that you hear about, rockets and satellites and those kind of fun things. And we didn't worry a lot in the embedded world about this whole network thing. That's been changing in the last 10 or 20 years with the Internet of Things coming along, where we're now hooking everything together, right? And my friends in the embedded world, 15 years ago, I started saying, be afraid of networking and security and things like that. They said, we're not, because we're just isolated in our car. A few years back, I was at a conference, and the information about the Jeep being hacked came out. And it became the immediate conversation of everybody at the conference because Jeep's a car, and hacking it remotely, that was subject to a lot of embedded testers of a little bit of scariness. And so we have these devices now, and I'll come back to the car down there in the left-hand corner in a bit, but we're hooking all these things together. I don't know if anybody in the room has a pacemaker, but pacemakers can now be remotely hacked. And if you're working in the medical field, please worry about better testing and security and things like that. So that took me into test environments. And yeah, I've taught college and do a lot of teaching, so I put definitions of things up. I have the same similar kinds of definitions for analytics coming up here that the first two speakers had. For those of you that haven't seen me talk before, I don't read everything on the charts. So if you want some of this information, read the charts, talk to me later. I summarize things, but I don't talk everything on the chart. But working with some of the standards groups, we started, at least with some of the Japanese people, wondering about test architectures. We don't address those well enough. And computing test environments and things. Tom worries a lot about integration. And I worry about integration because if I'm testing my mobile phone, that's fine. But if I'm testing it with my watch, that's now integration. But if I'm testing it in an environment that's hooked to the outside communication, do I need to test that? Well, maybe not, because a lot of people don't. But maybe we should. How far do I take my environment? It becomes an issue. Then viewpoints, well, I'll cover viewpoints more in a minute. But most testers, I find, only have their personal viewpoint on what testing is. I'm going to show you, there's many other viewpoints that we need to consider in testing. And then software user. And when I say that word, I bet the majority of people in the room immediately thought human, right? Human user. But there's a lot of, and now with embedded devices and IoT, many more non-human users communicating system to system, back and forth, totally outside of the human connection. Do I need to test that? Do I need to worry about that communication? I'm going to advocate I do as we get through this. I think Eric mentioned a good friend of mine, Dr. James Whitaker. He and I have talked a lot. I live in Colorado. I'm a skier. I've tried to kill off several very famous testers on skiing, including Dr. James Whitaker. I never succeeded in killing anybody off skiing, but Dr. Whitaker skied with me, which was a big mistake on his part. But he outlined 4 things all software does. Basically, input, output, internal data stores, and processing. And he wrote books on this. I added to that, based upon the embedded world in IoT, things like performance. And it was embedded in his stuff, but I really, talking with him, said, we care a lot about performance. We care about hardware in a lot of this world stuff. Yes, he was on a PC. Yes, that's hardware. But it was very generic to him. The kind of worlds that I come out of, and a lot of you are moving into, the hardware is all rather specialized. And so all of a sudden, as a software tester, I have to start thinking hardware and hardware kinds of issues. That can be a little bit difficult for many of you. I also needed to think these support environments, this big picture of the world I'm in. Who owns that? Those are the kinds of things that I started worrying about. And the driving force for me in worrying about these things came out of data analytics. And those of you who've seen me talk before, you'll see some familiar things. If you come to some of my other sessions, you'll see I've got some common charts and themes that I run through every year. But I looked at large amounts of data, whittled that down to a few pieces of data that I used, but correctly pointed out by the other speakers so far, the amount of data that we're generating is huge and growing by leaps and bounds. How do we process that? Becomes a big issue. We're going to hit some of those things. They talked about it a little bit already. So I looked at this big continuum of data on these systems that we have. All the way from kind of the left side over there is embedded. The right side is the big mainframes in the cloud that sits off there that most of us never see, but we use all the time. A lot of us have PCs, and a lot of us work in the mobile and smart space. I go around the world now. This is the normal position of everybody these days. I'm holding a little phone and like that. It's like everywhere in the world. I've been to third world countries, they're still all doing this. It's become a universal position of humans in that middle thing. And Internet of Things is coming out there. And so we're getting data now from all this stuff. Limited data out of the embedded world, yes, but that's now changing more and more. Internet of Things, the amount of devices being talked about, the amount of data being talked about just terrifies me. I don't know how to process all that stuff. And so these things are all going to come together. Few things mentioned: social media, help files, help desks, errors. Again, large amounts of data and drive this stuff. So I started thinking, actually many years back, about artificial intelligence. When I was going to, I think Tom talks about continuous learning. I've done that. I went back to school at one point and played around with neural networks when they were in their infancy about 20 years ago. And deep learning now gets called, and fooled around with some metrics, software errors and software code and things like that. And so it's got a history. And when I fooled around with it 20 years ago, it wasn't exactly mature. It's now matured quite substantially. We've mentioned Watson and IBM's tools, and pretty much all the big boys, Google, Microsoft, pretty much everybody has something going in this area. And so it's coming to maturity. And I'm going to give you a little bit of history on what I saw with it, and maybe a little bit of where you should be looking at personally. So machine learning definition, algorithms that can parse the data and look for, through terabytes, exabytes, I don't know what the next thing's past that, but huge amounts of data that humans can't, I don't know how to process a terabyte, let alone the other ones that are out there in constant data streams. And deep learning, usually some kind of neural network, and there's all kinds of neural networks out there. And while I've fooled with them, know a little bit about them, I won't claim to be an AI expert. I know just enough to, I'll say, both be dangerous and maybe point you guys in some directions on these things. But these are kind of modeled on the human brain, is why they're called neural networks. We think, in part, this is how your brain works as wired. And yes, the little figure down there at the bottom is extremely simple, because if I tried to map your whole brain out, it would kind of fill the room and be totally nonsensical. So, but this gives you an idea of these things. There's an input layer where a series of kind of inputs. There's actually a series of hidden layers where the relationships get formed out, and then you get an output layer. Is how these things work. And they've been around for a long time. They're now getting quite sophisticated. I don't know. I would like somebody to tell me how these things are working. I know just enough of what they publish, but I believe they've now merged neural networks with what we called case-based learning, with some other forms of AI and kind of grandiose, very cool, very intelligent looking system. But it's just processing data. It has yet to really pass tests that some of us would be able to tell that, yeah, you're working with a computer, but they can do things that you and I can't do on these things. So the training, I'll come back to that, but the training of these things, you have to have training data sets that you give these. And that's what's gone on with like IBM Watson and things like that. The data version, the medical version. Medical version, they've had it read in like every single medical paper ever written. And that's the training sets on these things. Massive amounts of data that no human can get their mind around. And these neural networks, they do go through a process of what's called balancing. They learn weight, so that when you put an input in there of a certain type, it ends up in a different place on the output based upon the weights on the inside. The hidden layers are what drives all that. It's Facebook's got the convolutional network, I think they call it. Again, they're only putting bits and pieces out of what they're doing, these things. I hope they give us more. I think they want to sell us buying these tools and things like that. That's okay. So, more neural networks coming up. For those, that's a little bit of introduction for those of you that haven't seen these kinds of things before. Again, a lot more information necessary. There's entire books and college classes and thousands of people working on this stuff, so it's just the top layer. But analytics technology has some pillars that they put out there. Speed of development, we heard about Agile and being very quick. We want these things to be quick, not just on the analysis side, but looking forward and the predictive side, real time, looking into the future. Data processing, real time or near real time. And your car is being driven by AI, you would definitely want it in real time. You don't want it to be just half a second late, because that may get you into a crash. The speed of deployment out of the DevOps world, constant, continuous. Now, some of us are not sure what that means. Do I want the AI system in my car updated while I'm driving it? I don't think so. I don't think I want it to go down or have it pull over and go, sorry, I'm doing the update. You know, like my phone, you know, does an update every so often. Usually, like when I want to make a phone call, you know, and like, it's updating, or in the middle of the night or something. And the speed of response to the users. We want people to be taken care of. But even more so, I already said, it may be the hardware that wants to be taken care of. Because I view hardware as a user. And we want the correct answer. Now that's a funny one, because how do I know what correct is? That's, by the way, the fancy name for that in the test world is called the Oracle problem. We don't have a good solution for that yet, totally. So we all struggle with that. You, when you're testers, are one of the best oracles that we have right at the moment. Because you're smart. Well, hopefully you're smart. If you listen to the experts up here, you become smarter. I think we're going to need these AI systems. And Whitaker said testing is dead, right? We heard that from Eric. I talked to him after that. I was at the talk and some of the earlier ones. Really, the whole phrase is old-style manual testing is dying. Okay, that's really what's happening. So those of you that are just manual testers, typing away over and over and then retyping the test script over and over, be worried about your job. Okay, it's really what Whitaker was talking about. The analytics people, the test designers, the test planners, the modelers, we've heard a little bit about modeling. I personally believe those kind of testers will be around and in demand. But if you're doing repetitive testing tasks over and over and over, yes, automation is likely to replace you at some point in the near future if it hasn't done so already. That's what Whitaker was talking about. Now, Whitaker and some of the others, and we get paid money to come up here and say inflammatory things and controversial things. James is really good at doing that. At that conference, by the way, several of us experts at lunch were sitting around and we were inundated with people going, are we out of a job? Are we all going to starve? And I was like, you had to listen to this whole story. But it is a concern. And analytics is going to be one of the things that you all should be thinking about personally becoming knowledgeable in, if not experts in. And analytics is already being used by some people. Managers use it. Developers are starting to use it. But I don't see a lot of testers using it. And you come to some of my other sessions, I'll talk about error taxonomy models. I think somebody mentioned that a little bit. And yeah, I do the same thing. An error taxonomy model looks at your error database and looks for trends in it. I asked yesterday at some of the sessions. Usually somewhere 0.5%, 1% of testers use that data. You all have it, but nobody's using it. And it's like, why aren't you using the data you have to at least understand these things? Let alone things like artificial intelligence. So for years now, I've been talking about using data analytics in the form of test error taxonomies, teach classes on it. People just kind of say, well, it takes a lot of work. Yes, it does. But good work goes rewarded. And the error taxonomies I created in projects years ago, I did it largely on my own and was rewarded first off with promotions, and then people at corporate pulled me away and sent me around the world. You may not want to do that part, but you can get rewarded on these things if you work on this stuff. And you know, if you look at these things, yeah, the data's out there, but companies like Ford has a full-time analytics team looking at the data coming off their car. There's a message there, okay? Now, yeah, they're looking for development and they're looking for improvement of hardware, but I hope some of them are looking at improvement of their testing. Because if they can see problems coming off of their cars, they may be able to improve the software in the cars. And by the way, if you're driving cars newer than about 10 years old, there's a lot of software in the car. And if it's only 1 or 2 years old, there's huge amounts of software in the car. And we're looking not just at self-driving cars, but kind of these, what they call level 1 cars, huge amounts of software, and it's buggy sometimes. True story, I have heavy equipment, like a bulldozer. I live on a ranch. Weird for a software person, I know. My bulldozer has a software bug in it. I've encountered the first time I was driving the bulldozer, engine's running, it stops. Middle of the road, just stops. Running, won't move. Guesses on how I corrected the error. Tom's heard the story before, that's not fair. Yes, I turned it off, but you had to turn it off for 30 seconds to let the computer power down. Okay, if you just turned it off and on, the computer still had power, it wouldn't power down. But if you turned it off, let the bug fully dissipate, then it ran fine. Software's in everything on these things. So Ford's got an analytic team. So this analytic model that I started thinking about, social media, start looking at that for data. Management, I don't care so much about them. Yeah, I have to live with them, but I don't care so much about them. I don't care much about socials and the selling side of things. That's the advertisement and the marketing people. Yeah, they're important because if they don't sell stuff, I don't have a job. But usually, I don't care so much about what they're saying on things. But I do care about the engineering side of things, the hardware, the systems, my test people, maybe the operations folks. That's a data source. So these boxes that are highlighted are things that I kind of go for. A lot of our systems, we talk about usability and what that means. I probably should care more about that, but I still struggle with psychology and sociology of these devices. Maybe somebody will be smarter than me and figure out how to do that stuff. But I do care about raw data, things coming off of the sensors. Like my bulldozer had sensors. It turns out if I adjusted something while the thing was moving to make it move faster, it didn't like that. It liked to stop and wait while I adjusted the speed control when it wasn't moving. That was raw sensor data that was messing me up. And the big one I talk a lot about in my classes and all over the world now, and every chance I get, security and privacy on things. And people go, well, what's private about my car and secure? Well, the Jeep people that got hacked kind of showed what was important about that is you can cause the car to crash remotely, which I don't personally want on that. So this analytics flow model that I started looking at is what I want to show here. So this one we know, the development test where we all live, the developers are putting code out, I think John showed a chart, and I'm testing things, and yes, I agree, information is what I do, information about qualities. Errors are just one kind of negative qualities, but there's a lot of information that tests. And then I move out into the real world. This is where a lot of people, testers, stop paying attention. I'm advocating we want to pay a lot of attention to the real world going forward, where these systems are out there functioning and things like that. The DevOps world has started pioneering this quite a bit, where we start seeing the data coming back from the users in the field. John showed a very interesting tool where we start using that data that's coming across. I'm a big supporter of that kind of information, potentially in real time. As the system's out there being used, it can flow back into the development team, and if we spot an error, we can fix it right away. Facebook, at a few conferences, had advertised their goal. They don't achieve it all the time, but their goal is a 24-hour turnaround from the time an error is seen to they figure out the problem, to they write the code, run some tests, and put it back out. Now, that's very optimistic of them. They may achieve it sometimes, but that's a very fast DevOps cycle, 24 hours. That's real time, certainly, things. But then there's this ongoing analysis that I think we need to be looking at. Because all this data flows into the cloud. A lot of testers go, well, I don't have the time to go into that cloud. I don't have the time to do these things. I'm advocating maybe you do. Yeah, you may have to do it a little bit on your own and do it on the side. But if you have access to the data, that data is out there. And even better, if you've got something like an AI tool or an analytics tool kind of running in the background, checking things, it may be providing some of the data like John showed that I can quickly look at and go, oh, I never tested on that platform. Very good example. Doesn't take me but a couple clicks, right, to run that kind of thing. On the security side, a tool called Shodan allows me to look at everybody in the room here and all around here in KL and see what systems here are running default passwords. Why would I care about default passwords? Huh? Security, yeah, I can log onto your system because the default passwords for most of these devices are known. That's stuff all out in the cloud right now. It's there. And publicly available, which is kind of terrifying, by the way. And so we want to benefit from these things. The data's out there. You have access to the data. You have access to your error logs. But nobody's using it. And I was in India a month or so ago talking to them. They didn't like what I was telling them. Okay, so I know I come here to Malaysia a lot, and people go, how do we compete with India and China? You know, and their billion-plus people. Well, the answer that I'm going to give you back is they're ignoring a lot of this stuff, at least in my opinion. They didn't like what I was saying on some of this data. You have the opportunity to come along and, I'll say, beat them at that game. Because it doesn't take just a few of you doing this stuff to beat them, because they're, I don't want to say ignoring me, they just didn't like the story I was telling them. So, some more on this neural network stuff. When I train my neural network to do things, I fed in all kinds of data on the code, error logs, every kind of metric that we could think of into the neural network. I had a training set, ran it, and I was telling Madam Aziza, when I analyzed what the neural network learned, it learned that programmers that write more and better comments make fewer errors. That wasn't what I was expecting. I was expecting things like complexity and McCabe and these things. That's what I thought the answer was going to be. It learned something else. And I actually did some research. That's actually a valid thing. Programmers that are meticulous, write better comments, write better code, make fewer errors. That's one of the things you got to watch with neural networks. They will learn unexpected things. And it's not that they're wrong, it's just that you have false expectations on these things. So the air taxonomy stuff, I'm not going to talk about here, talk about it a little bit this afternoon and more tomorrow, but we're going to drive test categories and changes. AI is going to drive a lot of areas that you may care about, all the way from security to manual checks to validation, sample analysis, cross-system validation, a lot of things that a lot of you go, well, I don't care about that, but your jobs are going to change. That's my message here on this chart. So some architecture things. Skip over that one real quick, and I want to get to the architecture mind map that I did. This is not a complete picture. This is an example. But these are the things when I talk about architecture, and if you don't know mind maps, you should go look at them, because some of us put this together. It's been reviewed at a couple of IEEE academic conferences. And basically what it's trying to get at is, yeah, tools are important. It's up there on the top. Environments, the real world, that's all important. You're supporting processes. Yeah, I support ISO and ISTQB and those things. They're important. The products are important. But there's one that's a little funny. Documentation starts being important. The viewpoints, developers, testers, managers, ops, stakeholders. But then the users, there's hardware systems, many kinds of humans. And I'll talk a little bit about that. I have to think in my testing environments about novice users, first-time users, experienced users, expert users. But then I also have to think the bad hacker guys. They're a user. They're not the ones I want, but they're a user, and I have to think about them. So when I'm thinking about my test architecture, it isn't just my test concepts and my test tools and the hardware and the software. It's all of this stuff. And if you get the idea, that's hard and complex, yes. And when we talk about architecture and we work out in the standards, I think this is what we're going to end up looking at. So these products, verbalize that. There's many of these kind of environments, and we're going to be figuring out on these architectures in the coming years what to set up and test on. Do you test just the individual device? Do you test in the factory you're in, or do you test in the city or even the country you're in? And the answer is probably going to be yes on a lot of those things. Test architectures have to address a lot of things. The analytics indicate that I've looked at so far that most test teams just focus on the piece of software, just the device. They don't look at the integration into the outside world. We more and more are integrated. We have to look to the outside world and at least say, this is where I stop at, so that somebody that's using the product knows, oh, I'm plugging into the house. I'm now responsible for testing my house. Not too many of us know how to do that, but it's nice to know that the house needs to be tested by somebody. Maybe a good job opportunity, for people testing smart houses as an example. So I started thinking about environments. Okay, what environments do I have to test in? Well, I started, and you can argue about the classification scheme, but there's the industrial side of companies. There's the consumer side. I've got my watch on here. Got talking to the phone over there. Personal. I don't have any medical devices, but a good friend of mine has a medical device that checks insulin, that talks to his phone, that talks to his doctor. Those are all environments that he needs to worry about. And then there's the middle sector, and that's probably going to be the big one of things like transportation, communication networks, safety, retail, and stores. You're all aware, at least depending on how you have your phone configured, when you walk around stores, they track where you're going and what you're looking at on a pretty regular basis. I turn my things off so it has a slightly harder time. I'm probably paranoid, but then on the other hand, they are out to get me, I think, so I'm not that paranoid. So the mind maps, again, a lot more complexity in some of the classes I do. I talk in greater detail, but these are the kinds of things some of us are looking at and worried about. And if you're not thinking the bigger picture, the message is you should be thinking the bigger picture of these environments that are out there. And the reason for that is most of us have some kind of bias. Now, I get in a lot of arguments with testers and friends and family. They go, I'm not biased. Psychologically, everybody's biased. It's just part of human nature. I can guarantee you're all biased. As good testers, we need to start spotting our bias and overcoming that. And the classic example that I use is people say, oh, I'm not blind, I'll just close my eyes and that makes me blind. Not the same thing. I had a student that was really blind. His view of the world, I can guarantee, is totally different than anybody in this room unless you're blind. That's a bias, an example of a bias that makes us not as good at testing things. So here's an example of these viewpoint things that bias tries to start to overcome. A connected automobile. Well, there's the non-human users, and sub-targets over there are various kinds of hardware communication, and then I've got examples on the far right side. There's the human viewpoint, there's the developer viewpoint, there's the tester viewpoint, that's all of you. There's the management viewpoint. Believe it or not, they have a different viewpoint than either development or testers, and usually they're just wanting to get the thing out. There's the operations people, and then there may be some stakeholders, and the list would go on, by the way. Again, just an example. So when I start thinking testing, and I go into my architecture and then my environment, then I go into this kind of list, it gets really big. My test plans are huge on these things. The message there is, if you're just testing like that much, you're not testing enough on this stuff. So, an example of this is the connected cars and errors getting missed. And by the way, cars are going to become self-driving. It's inevitable. It's going to be better. But we're at a transition time now, where some of the connected AI cars are doing some weird things. The example up here is there was one in California. The car was reading signs. It was looking for speed limits. There's a road in California called the 105. They read that as a speed limit. Yeah, not the right speed limit, right? But, you know, the car was trying hard, you know, and by the way, you know, you're supposed to keep your hands on the wheel. We all now know that a lot of people are not keeping their hands on these cars, and they're getting into crashes, and the car manufacturers are going, you weren't following the rules, but if you're dead, that doesn't really help you. So I've talked a lot of these standards and things like that, and you know, I'm a writer of standards. I'm not going to talk about them, but we've got these things out there. Some of the other people mentioned them. They can help. They're still evolving. They're not great, but you probably should be aware of them too. And was mentioned risk-based testing. A lot of risk-based testing. But here's a scary chart right here. This is just a small sampling of risks out of one of those embedded in IoT environments, and this isn't all of them. This is just a sampling, and I could probably make it 4, 5, 10 times bigger than this. I would test all those risks. Becomes a big issue. So we drive this stuff with analytics is what I think will start to happen. And by the way, the reason the car, that car is driving to Colorado, and right near our house, lovely wife taking a picture of the car. That is on a test system. The road that we live on is part of a test track. They drive cars around. The reason we know, if you look really close, the car is covered in drapes. What you don't see is there's a car trying to cut my wife off because they can see her taking a picture of the thing. The cars haven't been released to the public. Why are they testing in the Colorado environment? We do this in the classes, but I'll give you the answer. We have really nasty roads. We have a lot of snow. We're very high. We have roads that you can drive, dirt roads at about 100 miles an hour if you're crazy. Or is pointing at me saying, yes, I don't drive 100 miles an hour, but I drive probably too fast. But they like that on the test vehicles. because there's not many places that you can do that. Colorado is one of them. But it gives them this architecture stuff. So this is a list of questions you can ask yourself. And again, hopefully you can get access to these charts. I don't read everything. But I like to give people checklists to think about architectures and environments out there. And I came up with a list just to show you how complex I've got my environment with the car I just described. But I've been into companies like Airbus. They have something called the Iron Bird in Toulouse, France. They would not let me play with the Iron Bird. I was like, cool, can I run some tests? And I went, no. I keep trying, but it's a plane that can never fly, but they can put different hardware and they can run tests. And they've got all the hardware and all the system. It's a pretty cool environment, and I was helping them improve their testing. There's the auto industry, there's test bed cities. Anybody heard of chaos engineering? I love chaos engineering. I like the name, I think, most of all. But there's some of the bigger companies, Netflix, Facebook, some of the Silicon Valley players. They're doing something called chaos engineering. I got a chart coming up on that in about out of time. But there's a lot of potential environments out there. And these are specific examples of things that actually work and exist in the real world. These are things that I've seen or participated in, or at least had a wife that they tried to cut off on this. And so, mentioned model-based testing, and I have stuff coming up on that tomorrow. But in model-based testing, we do the automated testing, but we start with the customer needs. We generate some models on that, generate the software. We do a similar set of things on the test side. Why do I mention? Because what we're advocating now, coming out of the working groups I do there, is that you have developers doing their models, testers doing independent models. You don't want to use a developer model in your testing. And there's a lot of reasons for that. But we come to that. We can do comparisons. We can then generate tests. Feeds into an automated system. And all of you manual testers may be out of jobs because I can generate literally millions of tests and run them in the cloud almost overnight. That is future. No doubt about it, John. It's future. But I know of a few companies, mostly in Germany and Switzerland, that have been doing that already. And it's a future thing, but it's coming. So if you don't know these things, I really encourage you to go look at them. I mentioned chaos engineering. That's an interesting one. What that is they have test systems, and they're running their tests, and they're separated. They've got their hardware, and they've got a firewall separating them. And then, I believe this is how it works in Netflix, at some break point in time, usually late at night, they take the firewall down, they connect the system they want to deploy, which is running on a bunch of servers, into the real world. And then they start doing some perturbations on it. And occasionally we see Netflix and Facebook and things like that, they crash for a short period of time and then they come back up. My guess is they don't publicize it a whole lot. My guess is chaos went true chaos and then brought the thing down and brought it back up. Why do they do that though? Because they want to do that real world, okay? They can't really duplicate the number of servers and connections and users out there. So when they want to test the system in the real world, they have to put it in the real world. But if there's a bug, that's the chaos side. And they have conferences on these things. I thought that was just a cool name, but it's a kind of a cool concept. So bringing this together, I encourage Malaysia to prove me wrong. Do some of these analytics things. Come to the sessions on error taxonomies. Finally have somebody start doing some of these things. Maybe there's the future Malaysian AI V&D analytics lab out there that could beat India and China, maybe even the US on things. It'd be cool to see that. I've been coming here for about 5 years now, babbling about this stuff. I'd love to come and have you guys educate me on what you've actually done with this thing. Personally, and I've talked a little bit about how you could do these things, but not your organizations, you personally need to be working on some of these things. And here's a whole list of them: data analytics, government departments, you can do this, companies, you can do this, model-based, you can do it, get involved in some of the labs going on here in the country. You do it personally. I did it some of my own time. I got good enough at it. The company, the projects I was on did it. I got good enough there. Tom hired me. Well, sort of hired me. Stuck me off in another department. I never really worked for Tom. I worked for other people. But I got good at doing this stuff, and I started on my own time in group. You can do that too. And if even just one or two of you in this room do that, then things that I've been talking about with John and Eric, we've been successful. That's the best I can hope for, is just one or two of you doing that stuff. So, went through this fast. I always have too many charts. You can look at them. Love to get emails, love to get questions on things. And I'm here the rest of the day and tomorrow. And so, but analytics, AI, these are definitely coming. They're going to influence testing. And testing isn't dead, but testing is going to change. It really, really is going to change. And with that, I think I'm done. A couple minutes late.